till now we have learnt about some constructs of programming to implement some very generalized structures, programming structures, right. What are they? First, we have seen how we can do branching, right. And branching means that whenever there is a sequential flow, we take a decision we come to a decision box, and depending on whether the result is true or false, we take different paths, right. That is what we have seen, and that is implemented by if else statement, right. We have seen that. The other thing that we have learnt is repetition or looping, all right. That means, we have come to a particular point, we take a decision, and based on the decision we decide whether we will go back to an earlier point or we will continue forward. Okay. So, this repetition we could achieve by while statement, do while statement, or while do statement, or for statement. So, if else and do while do for, all these are constructs in the C language, whereas the concept of branching and repetition or looping is general for most of the programming languages. So, this is a general concept, while this is a specific construct corresponding to the C language. Now, to start our journey into the world of real examples, let us first start with the school level equation solving. When we try to solve a quadratic equation of the form ax square plus bx plus c equals 0, we tried to solve it, means we wanted to find the roots of the equation. Roots of the equation of this form. And what are the roots? The roots are the values of x that will satisfy this equation. For example, I can have 3x square plus 5x plus 1 equals 0, all right. What are the values of x that will solve this, right. So, we know that we can solve this general equation by the well known Sridhar Acharya's method, that is x is minus b plus minus root over b square minus 4 ac divided by 2a. By this we can find the roots of this equation, and since it is a quadratic equation, how many roots will be there? There will be 2 roots. We also know that if b square minus 4 ac is equal to 0, then this part will be 0. What will be the roots? Roots will be minus b by 2a only. So, there will be two roots which are equal, the same roots. For example, if I have x minus a whole square, that is equal to x square minus 2ax plus, what will that be? Plus a square, right. Now, if I saw and if I say that this is equal to 0, from here I say that this is equal to 0. If I solve it, I will make this as x minus a whole square, and that means x assigned a will be the root, right. That means x minus a is 0. So, x, both the roots will be equal. So, if I have root over b square minus 4ac equal to 0, in that case I will have both the roots equal. If root over b square minus 4ac is negative, we know then our roots which are minus b plus minus root over b square minus 4ac by 2a, if this part is negative, then the roots will be imaginary, right. If b square minus 4ac is greater than 0, then we will have real roots, right. And the real roots will be minus b plus this and minus b minus this by 2a. Okay. So, that will be, that is a school level knowledge that we have. Now, if I want to apply this knowledge to write a program that can take as input any equation of that form ax square plus bx plus c and find its root, how will the program look like? Suppose I want to write such a program, and now henceforth in my discussion about this problem, I will call this b square minus 4ac to be the discriminant. I write it for short DISC as the discriminant, because that is what is telling me discriminating between the roots, DISC. Okay. So, whenever I refer to discriminant, that means I am talking of b square minus 4ac. Now, I want to write a generalized program for finding the roots of ax square plus bx plus c, so equal to 0. So, I want to write a program that will be equally applicable to solve this root, this equation, solve this equation, or 25x square plus, sorry, here I should not write c, let me put it something like 5, 25x square plus 17 equals 0, or any such equation. So, you see here what is the coefficient of x? Coefficient of x square is 25. What is the coefficient of x in this equation? It is 0. That is why this term has vanished. And what is the value of c here? It is 17. Whereas, in this equation the coefficient of x is 3, x square is 3, the coefficient of x is 4 and the constant term is 5. Okay. So, since I am going to solve any general equation of this form, how can I define the specific equation? an equation of this form can be specified by specifying the coefficients. So, I have to accept the values of a, b and c from the user, and you can see that the root is dependent on the value of these coefficients, because we know the root x is minus b plus root over b square minus 4 a c by 2 a and minus b minus root over b square minus 4 a c by 2 a. So, the roots are determined only by the value of these coefficients. Therefore, the first step that I will have to do here, we can start with a flow chart. So, I will first write read A, B, C, read them from the user. Then I compute find discriminant equal to b square minus 4 a c. I just compute this part, b square minus 4 a c, because depending on this we will have the different values of the root, or I would say all right. So, now so earlier probably I said that the discriminant is root over b square minus 4 a c. I would like to correct myself. I would say discriminant is this part b square minus 4 a c, because depending on the value of this, if this is negative, then the roots will be imaginary, because the square root of this will be imaginary. Okay. So, this is the discriminant part. If this is 0, then the roots are equal. If this is greater than 0, then the roots are positive and real, and if it is negative, then the roots are imaginary. So, at this point I will make a decision. Discriminant greater than 0, yes. Then what shall I do? I will print roots are real, and then I will print the roots. If the discriminant is not greater than 0, then I come here and I check whether discriminant is 0. If yes, then my decision is roots are equal, and then I go and print the roots. If this is no, then obviously I will print imaginary roots, I can see this part, and then I will go and print the roots. That is the flow chart of the whole thing. So, I am computing this value, and based on that I am finding the roots. Now, if the flow chart is clear to you, let us proceed to write the program for this. Now, here obviously I should have said that the discriminant is actually this part b square minus 4ac, and then I take the square root of that. Okay. So, now if we start writing the program, if I am a nice programmer, I will always start with, so first of course, hash include stdio dot h. Then I am including another thing which is a library called math.lib. .lib stands for library. Why I am including that, I will come to that later. Okay. Now, we start our program main and we start. I can give a comment, program to find roots of a quadratic equation. All right. So, that is a comment, so that anybody can understand what I am writing here. Now, I will have to declare a number of variables. I will declare okay, let us say the coefficients are all integers. So, int a, b, c. Okay. Now, b square minus 4ac can be anything. So, I put float discriminant. Also, float root 1, root 2, 2 roots. Okay. Next, what should I do? Let me proceed to the next page. With these declarations, I hope you have been able to take down this declarations. Now, let us proceed and go to the next page. I am continuing with that. I start with printf enter coefficients a, then b, then c. All right. So, the user is told that he is supposed to enter the coefficients now. Next thing will be scanf. Since I know I can also say that please enter integer coefficients. I am just restricting it here like that, though it is not necessary. So, scanf percentage d, percentage d, percentage d, and a, and b, and c. So, what I will do? My system will read the 3 integers a, b, and c. Now, starts the main program, and as if you have studied the flow chart that I had shown here you can see that I have got only one decision box, and I can proceed through that decision box. There are 2 decision boxes actually, one in this direction, another in this direction. So, accordingly, I do not have any loop here. So, what is the construct that I will be needing here? The construct that I will be needing here is if. So, what should I do? First, let me compute the discriminant. All right. I have got B, A and C. So, I do discriminant assigned B square minus 4 AC. So, B times B minus 4 times A times C. So, this is an arithmetic expression. I get discriminant. Now, I will have to take the path depending on the discriminant. So, what I will write here is if, then a parenthesis for the condition, if discriminant is greater than 0, printf roots are real. And I can put a backslash n here. Else, I have not computed the roots as yet. Okay. So, let me write the else as close to the if as possible, as we have learnt about indentation. So, else if, I should have written this if also in small, just for the sake of uniformity, and not only for the sake of uniformity, C is very much case sensitive. So, capital IF is not if. So, if discriminant is equal to 0, printf roots are equal backslash n. Else, now this else comes under this if. You remember that else and ifs are tied up based on the closest, the else is connected to the closest if. So, these two else the only option is discriminant is neither greater than 0 nor equal to 0. So, discriminant is less than 0, then printf roots are imaginary, backslash n again. Now, so I have just said what type of roots they are, but I have not printed the roots as yet. I have not found out the roots. So, what I can do, I can modify this a little bit, or how do I find out the roots? Let me go to the next page. I do this and then I come back to a particular stage. Or I can do it here itself. How would I find out the roots? Say, let me go back and do it here. Here I have not written down what the roots are. How could I, suppose I modify this part a little bit. I modify this part a little bit. Okay. So, let me modify this part. I will rewrite this part, okay, in the next page. So, I rewrite it as if disk is greater than 0, printf roots are real now I compute say I compute let us call it I should have declared this also discriminant 1, another part, that is oh, I had the discriminant part. So, I can certainly make another variable so I add one more variable here, int a b c, and here I enter another variable, say d y, I will show later. So, I have entered another variable there. So, printf roots are equal and d is square root of disk. So, I called disk to be b square minus 4 ac. Now, I am finding the root of that. Now, here I have committed one mistake. Can you tell me what the mistake is? So, this discriminant can be integer, but when I take the square root of that, it can be a float, right. And also here I have already declared, if you look at, I somehow declare disk as float, but since a, b, c are integers, then this will also be an integer. So, I should correct it a little bit. Okay. What should I do? Or it really does not matter if I keep it as float. So, only thing is that I cannot keep the d here. I will have to remove this d, all right, and I will also remove this and will make this small d as a float. So, then I come here, d is square root of the discriminant. Okay. Now, what is this square root? Who will compute this square root? This square root computation is done by an inbuilt function in C library. C compiler provides us with a library of some inbuilt function, mathematical functions, which we can call and invoke whenever we need them. Okay. So, you can see here, that is why I have included this math.lib. That means, I will be using some library function here. .lib means library. So, you will find in the course of this lectures and more examples, where you will see more number of library functions, but just for this we need the square root function. So, I compute the square root of disk, okay. D assign the square root of disk, and then root 1 is what? Root 1 is minus b plus d by 2 a. Is it clear? The two roots, one is, I have my formula is b plus minus root over of b square minus 4 a c by 2 a. So, this b square minus 4 a c is d here, all right. So, b plus d whole divided by 2 a, I should also put a parenthesis here, is root 1, and root 2 is minus b minus d divided by 2a. Then I have got the two roots and I can print here. So, I have computed the roots. So, I can either print it here, I can printf. Now, the roots can be float. I can say the roots are percentage f, roots are floats percentage f backslash n and root 1 comma root 2. So, this is the whole part compound statement if disk is greater than 0. So, if we go up, so I will modify this part in this way. You will also have to modify this part. What should you do? Simply, what can I do to write this? If disk is 0, then I will print roots are equal, right, as I have written roots are real, and then I will find out. Now, I do not need to find out this part. So, let me just show you this part and I will leave the other part for you. That second part, if disk, oh my God, what did I do here? Oh, this is all right, that is okay, greater than equal to. If disk is 0, then printf, there is more than one sentences. So, this is coming else, that else part, else if disk is 0, printf the roots are equal, and here I do not need to bother much, I can put a backslash n, that you know by now. Printf the roots are equal, root is what now? If in this b plus minus root over b square minus 4 ac by 2a, if this part is 0, then my root is only minus b divided by 2a, 2 multiplied by a, okay, and printf the root is percentage f backslash n root, or I can say root 1, because I did not declare anything as root. So, root 1, any one root, that is same. Okay. This is this part if the discriminant is 0. See, yeah. So, I have just mentioned root 1. Why? Sorry. You see here I declared only root 1 and root 2. I did not declare any root. So, I can make root 1, root 2. Now, so this is replacing this part. Now, what will you do here? The roots are imaginary, but the same thing, the values will be the same. Only thing is, roots are imaginary. I leave it to you as an assignment. You think of how, what will you do for that part, okay, for the imaginary part. You can understand that only thing that you need to do is to print some roots as, say, the real part is this and imaginary part is this. So, you think about it, we can discuss about it in the next lecture.